It has taken us a long time to reach some of these conclusions and to think really deeply about them. But we are tremendously excited to announce that starting with today, Elrond essentially transforms and expands to Multiverse X. Now, with this new vision, our entire set of products is essentially imbued with an expanding meaning and value. A new constellation of products will be enabled. The key idea that we'll repeat over and over again is that we're trying to enable people, brands, organizations, companies, and countries to build new apps, new economies, and new worlds, and scale them across the multiverse. As I've mentioned before, the metaverse cannot exist unless it is built on a high-performance blockchain infrastructure, one that can scale, that has negligible costs, and that is carbon negative. It's great we've built one, just like that, a long time ago. Now, let's take a closer look through this new perspective at everything we have built so far, how these pieces fit together, and how together they create an unparalleled, extraordinarily resourceful ecosystem for both the physical world and building applications within the physical world and applications within the metaverse space. So with this, I'll invite my colleague, Adrian, to go through the process.
Thank you, Benjamin. Hi, everyone. My name is Adrian Dobrița, and I am Elrond's head of engineering. One of my core roles is architecting the Elrond protocol. This is a set of rules that internet computers, also known as validators and observers, agree to follow, forming thus the Elrond network. We have been developing this since 2018, with a mission of creating a highly performant, high-throughput blockchain network that can operate at internet scale. Clicker, sorry. Thank you. Okay. The Elrond protocol went live in July 2020, and it started as a 1,000 times improvement in terms of performance and efficiency over the existing blockchains at the time. Our lead was impressive, and our opportunities ahead even more so. So we kept doing what we did best, building, innovating, improving. Today, thanks to improvements done to the Elrond protocol, the network is capable of twice as much throughput. This is mainly due to features such as scheduled transactions and partial mini-block execution, which brought a huge improvement to our throughput. So the scheduled transactions is a feature that we've activated this year, and it increases a lot the throughput of the network by doubling the gas per block, and doing so at a very minimum cost to the consensus. We were able to do this by using the validator's idle time for extra processing. The partial mini-block execution improves the rate at which we fill the blocks with transactions by changing the constraints we've added on the cross-shard operations from a mini-block, which is a set of transactions, to the transaction. I've inserted here a graph. I won't go into details. If you're curious, you can take a picture and we can discuss it afterwards. So basically, this is how the partial mini-block execution goes. In addition to being more performant, the network has also become much more efficient. At the core of this improvement sits a core network component, the heartbeat. This is responsible for passing along information between validators and about validators and observers and their status, and essentially being a very important component for the liveness of the network and also a core component of our network sharding mechanism. The heartbeat redesign brings a substantial decrease of CPU usage and bandwidth for all the nodes in the network, and this enables the entire network to perform much better using the same underlying systems. And I've put here a graph. This is the level of improvement brought by this redesign, and this is for all the nodes in the network. So this is average improvement. Now to the next. Faster processing. Now going further, the Elrond network is a vast ecosystem of users, smart contracts, and records of trust. We now have more than 2 million accounts in the network. It has processed so far more than 60 million transactions and over 300 million smart contract operations. This all resulted in significantly larger state. This state is the collective data describing the accounts, their balances, the smart contracts, and their data. And this one gets increasingly larger as we get more users, we get more smart contracts deployed on the network, and as the interactions between these users and the smart contracts increases. And it's becoming increasingly challenging to maintain the access time as minimum as possible, and also to make it the synchronization of this state, which is required for new nodes, to be as fast as possible. We tackle this by redesigning the state sync component and adding also a snapshotting functionality to ease the epoch transitions, which has proven to be one of the pain points. In addition to this, we are right now testing a multi-key node solution. I'm sure this one is interesting for all the validators. This one will completely remove the need to do the state sync for the validators already running in the system. And we'll continue also with more improvements on this area, state optimizations, cleanup measures, which will result in empty accounts cleanup, and the possibility to archive and restore unused state. We are also working towards transitioning to Verkle trees, and we're already working on improving the access time to the disk. And here, there's also some measurements of the level of improvement we've achieved in the tree sync. Each of these improvements were achieved thanks to careful design and implementation, and also diligent internal and community testing. We now have automated testing for functional testing for most of the built-in functions, and also for the staking and the delegation contracts. As well as we are now able to replicate the mainnet state in a shadow fork testnet in order to test all the updates and upgrades and fixes to the mainnet before actually deploying this to the mainnet. The testing part is especially important for rolling out updates that not only advance this functionality, but also preserve the security and stability of the network. The increase in the rate of testing or the speed of testing translates into the increase of the iterations on the new features and enables us to iterate faster towards other enhancements such as pushing towards 50,000 transactions per second in the current mainnet setup. So continuous protocol optimizations through features such as the scheduled transactions have given us some insights into how we can improve the network even further. In the current configuration, a new block is created every round, so around 6 seconds, and half of this time we can use for transactions execution. But we can increase this even further, up to 80%, allowing for even more processing. The next area we are exploring is increasing the number of validators in the shards. As you know, right now we have 63 on the shards, but we plan to increase this to 400 as we already have in the meta chain. We would essentially use the same model, which gives us some interesting benefits, such as instant finality for the intra-shard transactions, overall faster transaction execution for cross-shard operations, and also improved network security and resilience. We are also working towards a scenario where the round time, which is 6 seconds, can be further decreased, so we can improve even further the transaction processing. Now, these are possible due to other improvements we've done and we're still working on for the consensus and the execution model, in the way the votes in the consensus are being aggregated, and which previously took a lot of time. And now we've managed to reduce this to a constant time. And I'm sure a lot of you will appreciate this next one, guardians for accounts. Users will soon have a new tool at their disposal to further secure their accounts. This is similar to how two-factor authentication methods work. How will this work is that any transaction originating from a guarded account will be able to have a co-signer, which would be probably one of these services. It will carry, together with the user's signature, also this third-party signature, and it will be useful, for example, for people who had their keys leaked. For this, to make this usable for critical time applications, we are working on a service that we want to open source, which will be able to act as co-signer. Now, in order to meet other specific needs for various blockchain use cases, we will also develop a light client and add support for its requests and data responses on the existing node implementation. This will be useful in a number of scenarios, such as payments, message transfers, where reducing the full client to its minimum set of required functionality will provide an efficiency advantage. We are also planning of adding support for zero-knowledge cryptographic primitives in our crypto library, which, if used, for example, with the light client, will be able to create bridges between chains using zero-knowledge proofs. Yeah, and I saved the best for last, an advanced scaling method for products looking to supercharge their execution component. We are working to make available an SDK on which you could deploy the Elrond protocol in an independent chain. This will be separate from the Elrond mainnet, but natively interoperable with it. Such setups will be the perfect execution environments for high-performance